Okay, so it's been about just over 4 weeks, approaching 5 weeks since I uploaded my last video. My last video was the little oscillator that I built for weaving the welds. If you haven't seen that, go and check it out on my channel, it's quite interesting. So, okay, so where to start? This little video is going to be about a project that I started, must be 8 months ago, a long time ago now. So this is part 2. Part 1 and an introduction has already been completed. Wait till this car passes here. So this is part 2, as I say. This video was all about mounting the motor. So the motor is mounted in such a way, right, that I can be sort of independent between different speeds. So if you haven't seen the introduction one, or even the part 1, you should check it out. So I explain it in more detail there between the gears, the mechanical gears and the electronic gears. So in this video I will be demoing or doing uploading clips, well, putting the pilot clips together of me bringing this little project together. So there will be various video clips using lathe tool and stuff to turn down the pulley and make the pulley fit the motor, because the motor has an 8mm shaft and the pulley had I think it was a 16mm or 20mm hole in it. So I had to make a spacer for it, a little boss even, to slide into it, so it was pressed into it. So it was quite a bit of working to get it at this stage. So I'll bring the camera up in a minute before I move on into the video clips. So these video clips are created over the last month or so on my spare time, any spare time I got to do this little project itself. So the motor slides back and forward over a stroke of about 50mm. So that's to allow me to be to adjust between lower gear and high gear and intermediate middle gear. So what I'm going to do now, right, I'm just going to start with the video clips after I bring the camera up and just give a wee quick just a wee demonstration of where I'm at and where I'm going. So the tensioner is not done at this stage. There's no tensioners on the motor at this stage. So the tensioner that I was going to use was going to be a ram like this. So it's gas assisted, so it's high pressure. So I think it's too much, too strong. So if you can imagine you trying to push a motor in to slide it along a shaft, it'll be quite difficult. So what I'm going to do, right, is I'm going to create a little electronic ram out of this little motor that is used for a car seat, the adjustment of a car seat, so it lowers your back up and down, or different adjustment of a seat in a car. So this is off a Honda Accord, a big luxury legend car. So it basically has a little screw shaft, so it's like a linear screw. So I have to sort of turn this into like a, what could you say, an electric ram. Needs to have the right stroke. So basically I'm going to tighten and slacken the motor with a flick of a button. So I'm going to bring the camera up now, close to the motor, and we're just going to move straight onto the video clips. There's a wide range of them, and hopefully you enjoy. So take it from there. I'll just move her up here now, and what do we see? So we're in the garage today because it's quite windy outside, and this wee leaf's actually quite heavy to take outside till daylight. So hopefully you can see there nice and clear. So this is the stage we're at now. We have the motor on a sliding shaft like so. So basically what I'm looking to do here is I'm looking to slide between lower, mid and high gears. I got this little belt now to suit. So I'm going to move straight into the video clips now. This comes at the end of the video, of course, because there was a lot of work done around this pulley and all on the lathe that I got a lend off. My friend let me use this lathe for a couple of hours to get this up and going. So after that, part 3 will come in approximately 4 weeks. So that's it. I hope you enjoy all the video clips, and take it from there. Okay everyone, so today I got a lend this lathe to do work on my own lathe. So here we have a pulley that will drive the lathe using this wee motor. So what I need to do here now is make a bush. Oh, sorry, I already have the bush made. So basically the bush is going to be 12mm outer, 8mm inner to match the shaft.
So what I'm going to do here is I'm going to place the pulley on the motor this way. Then to reduce slap, because the shaft's obviously 8mm, I'm going to attach a bearing and sort of a bracket to the outer side of this pulley. Before I do that, I need to, well, this pulley is sort of for 12mm belt, V-belt. The V pulley on the lathe, the 3-stage pulley on the lathe that I shown in the very first part of this whole project, first video demonstration, you can see the 3-stage pulley is much narrower than this. So what I need to do here is I need to make this 12mm pulley fit this 10mm belt to prevent it from slipping. So what I'm going to do is I'm going to remove a little bit of material. So this pulley, I think it's for is it an A section belt? Well, I will be taking it on out to maybe sort of like a V. So if you look across it here, you can see it's not the two sides are not going onto a point. So I don't necessarily need to have them going onto a point, but I just need them, well, to allow the pulley to fit a 10mm belt, if that makes sense. So what I'm going to do is I'm going to start turning it down here, and then I will talk about it. Hopefully you get a better understanding then. So the smaller I make this point in here, that means the 10mm belt will fit the pulley as it goes in, and a side, the taper both sides even. So we will start up here now and have a go. Okay, so what we're going to do here now is we're going to place this pulley onto the chuck. I'm going to continue this edge on down into the sort of boss of the pulley, and do the same with the other side. Then we will try the belt on it for fitment and make sure that it is a nice snug fit and the belt is not spinning in the pulley, or the pulley is not spinning in the belt, should I say. So as it is at the minute. So here we go. Okay, here we go now. Okay, so that's one side nearly done. Now the other side. Okay, so what I've done here now is I've placed the bolt through the pulley just to hold the pulley in the opposite direction, so it's basically flipped 180 degrees even. So I can grab the bolt now and not the pulley instead, rather than depending on just holding the pulley with this edge to get on here with the cutting tool. So here we go. Move this out of the way a minute. Doesn't look too centre. I think it's because of the 12mm bolt. The threads is actually, well, smaller than a 12mm, if that makes sense. The shaft size of the bolt's 12mm. So we'll see if we can straighten it a bit better here. Ooh, up rough. Near enough. Okay, so back around now to the other side. Okay, I should mention here that I tried to get a pulley with small shaft size and small diameter for a 10mm belt, 10mm wide belt, but I couldn't source one anywhere, so that's why I'm actually doing this. So here we go again. Okay, so one final thing now is to just give it a wee tidy in the middle of the pulley. So hopefully now the 10mm belt shouldn't slip on this pulley. Okay, here we go. Okay, not bad. Okay, so if you look here now, through the pulley, you can see a little gap between it and between the belt and the pulley. So it's basically touching the two sidewalls now, which it wasn't before. So looking good. So next thing now is pressing a little spacer. Well, obviously removing this bolt, pressing this 12mm bush into the centre of the pulley. Then we will start turning this part of the pulley down for the bearing, and then we will make the bracket to support the shaft onto the bracket I currently made for the motor. So let's hope it all goes well. Okay, so now that we've got the belt fitting pulley, we have this little bush which places over the motor shaft, nice and snug. So it's stainless steel. What I want to do now is press that stainless steel straight into the pulley, and then we will start with turning this part of the pulley down for the bearing that will support the outer shaft, the sort of outer side of the shaft. So from this plate to the bearing. Okay, so it's a little dark here in this part of the garage, so hopefully you can see there. So pumping this bush into the pulley now, pressing it on even. There we go. So that's it. Little a swerve come behind it, but it's good job. Okay, here we go, first try. So you can see how tight it was there, the aluminium. Well, she sort of shaved a wee layer off the pulley a wee bit there. So it doesn't really matter, so it's nice and tight, you can see. It doesn't require any Loctite liquid or anything like that. So we have the pulley now in position. What I need to do now is bore a hole straight through here, through the existing hole in the pulley and into the stainless bush. Then I'll continue to tap the threads on through. So next thing now before I do that is I'm going to make this pulley fit this bearing. So this bearing's going to slide over the pulley. Then we will have a support on the outside of the well, on the outer end of the shaft. So we want to be welding whatever bracket here to this pulley, or sorry, to this bracket, not the pulley. Otherwise the pulley will never spin. Okay, so this bearing, the housing that encloses the bearing, will be welded or bolted directly to the bracket of the motor. So that will well, prevent slap of the shaft, and also when I go to tighten the belt up, the shaft won't bend or be out of place. So rather than just depending on the bearings in the motor. So let me start this here now. Here we go. Okay, so we have the bearing here. The bearing measures 25 inside, and the pulley measures 28.8. So we're going to start turning this down here now. Approximately 25 mils. So here we go. Cutting tool ready. Okay, 26.5. I will continue this here now off camera. Keep taking pictures through the different stages. So I hope you enjoy the rest of the video. Okay, so I finally finished this here now. So we have the pulley with the bush pushed into it onto the shaft. We have the 25mm inner bearing that slides nice and neat over the pulley. So the reason I've left it with a, well, not a tight tolerance is because I have to remove this bearing to remove the grub screw to remove the pulley if needed. So the surround or the actual bracket now that will hold this bearing, the housing, needs to be needs to be sort of fixed to this plate with bolts and not welded. The bracket can be welded, but it has to be bolted directly to this plate, being it's bolted at the motor mount points or the hinging points or 2 new tapped holes. So that's it finished. I now have to start making this housing that will contain and hold this bearing to reduce the slap at the end of the shaft and the tension that will be applied to it when it's holding the belt in position on the lathe. So I discussed there in the first videos, there will be a ram sort of pushing the belt like an auto tensioner. So that's the reason I need the shaft held at the very so it's not dependent on the bearings in the motor. So that's it. Moving on. Okay, so final wee stage here. So just tapping this little hole out for the grub screw. So through the aluminium pulley and into the stainless bushing. So this grub screw will hold the pulley, will keep it intact on the shaft. The grub screw must not protrude or extend past this point here, because there will be a bearing attached over the top of it, or placed over the top of it, to support the shaft and the motor. So I have turned this down already as demoed there in the wee video clips. So just finishing this off here now, tapping it out to 6mm. So that's it finished. Now I will place it on the motor and start mounting the motor itself. Okay, so I finally got round to tapping this wee pulley. So as you can see here, I have bored right through the pulley and through the stainless bushing that I have pressed in to the centre of the pulley itself. We now have a M6 grub screw, 10mm long. I think 10mm will be okay. So this now will tighten into the shaft itself. So all's good. Moving on now to mounting the motor. So I will need to make the pivoting mechanism that will alter the belt between the different stages. So here we go. Okay everyone, so next step now is mounting the motor itself. So I can either have the pivoting point at the top or at the bottom. I think I'm going to keep it at the top. So basically what I'm going to do here is create a bracket off the shaft. These 2 bushings will be welded to the plate, the motor plate that was made in part 1 on my YouTube channel of this little project. So first things first now, what I have to do is I have to find a location for the motor. So it's either going to be at the back of the lathe, around here, or around the front. So I have decided to keep the motor at the front of the lathe. Basically, to keep things simple, when I go to slacken the belt, to move it. So basically, this motor will slide on the shaft once you push the shock absorber in. To make it, well, a quick change of the belt, if I want to slip down to the lower gear or back up to the higher gear. So we're going to have a ram, we're going to have a spring or something like that that will push the motor out and keep the belt tight. If we want to slacken the belt, all we do is push the motor forward with our hand, and that's it. It's really simple. So what we're going to do now is we're going to find if it's the belts. I have 3 or 4 different types of belts here. So what do we see? I have V belts, and they're all different sizes. The one on the lathe at the minute is 545 mil circumference. So that's the smallest belt that I can get that keeps the motor as close as possible to the lathe to keep it from obstructing me walking past and catching into it and stuff like that. So basically you want the motor as close as possible to the lathe when it's on the bigger gear. It will, however, when I put this belt onto the smaller gear, what do we see here? You need to put a grub screw in this pulley yet. The motor will come out further from the spindle shaft, but there's nothing we can do about that. So what we're going to do now is we're going to start making a bracket here for the mounting point. We will probably mount to here, this point, and that's it. So I hope everybody will enjoys, and sorry, there's a tractor passing. I hope everybody enjoys. It's going to be an interesting me project, and I think it will work very well. So here we go. Okay, so we're ready to weld these two bushings in place. So this will act as the hinging point of the motor itself on this fancy plate that I have made. So this plate was made at earlier stages. See part 1 on my YouTube channel of this whole project to see how I made this. So first things first, I need to tack these two bushings in place now. The shaft, then I need to make a bracket that will be attached to the lathe. So here we go. So I can see a wee gap here, so I will tighten these up and weld them fully. Okay, so I have the shaft sliding nice and free. If I remove these vice grips, the shaft tightens up a wee bit. So it's important when I'm tacking this that I place the vice grips at the opposite end of the tack, as the two bushings are tight to the plate at the back, and they are now tight to the plate where the vice grips are positioned. So I can apply a tack here and a tack to the side, making sure that the hinging point is nice and loose while the shaft slides freely. Here we go. So that's it, tacked up. Now we're going to make the bracket for the lathe itself. We will weld this, well, when everything's sorted in the future. When the bracket's finished, now we'll start welding it all together. Okay, so I'm finally getting around to mounting the motor itself. In the background here, I've been working on two brackets that will support the bottom of the motor. One mount point, so one mounting point. So basically as seen here, we want the motor to slide in the shaft. So the two brackets will be in the outside of the shaft, well, the two ends. So the motor will basically be placed on here, welded into position, and it then can slide back and forward when I go to adjust the belt between the three-stage pulley. So what I'm going to do here now is I'm going to start mounting this, but first things first, I have to cut this shaft to the right size. Then it has to be positioned and welded. After this is done, we can move on to the adjustment point. So I either will use sort of, let me see if I can find it here, a shock absorber to tighten the belt. I have a smaller one, a 6-inch one of these. At the minute I can't find it, but I have actually come up with another idea at the minute here, and basically what I'm going to do, well, I'm thinking about doing at the meantime, is so I'm looking to maybe tighten the belt using this actuator, this linear screw. So basically push one button to tighten it and another button to slacken the belt. And I might put limit switches and stuff on it yet, we'll see. I haven't got round to thinking about it in detail yet, but we'll start now with mounting the motor on the sliding axis. So here we go. And And again, another tack here. I have lined the shaft up. So what I'll demonstrate here, just bring the camera off 2 seconds. Okay, so what I've done here, right, is I have lined the shaft with the bed of the lathe itself. So making sure that the shaft is parallel with that. Just so when you slide the motor, well, the belt lines up, the two pulleys are parallel to each other in line. So I'm going to put the camera on here now and give it its final tack before we move on to the bracket at the back of it. So here we go. Zoom in a wee bit here. See if I can get in here somewhere. So using a little bit of filler rod. So I says there with the mask down, I'm using a little bit of filler rod just to give it a wee bit of strength for the meantime. So that looks okay. So now moving on to the bracket at the other side of the shaft. So there was a wee problem here. So the bracket that I had currently made is in the way when the motor slides in and out. So I have to make a few adjustments. But it's working okay there at the meantime. So now I need to make the bracket go out in an L shape and to the end of the shaft, so it doesn't hit this bushing when it's on the first tier or the first stage of the pulley, if that makes sense. So I'll take loads of pictures and I'll keep rocking here. Okay, so before I move on and finish off this mounting point for the sliding shaft, or for the sliding point of the motor, I'm going to give a wee explanation on these gears. So you can see here at the minute, the motor is, well, it's very fully stretched out. So this is the highest gear possible on the lathe. Well, highest mechanical gear, and then you have all the digital ones that will, well, hopefully they will work in the end up. So, so the highest gear meaning here, the spindle shaft will be running at its fastest rate when I get it going. There'll be less power there, but there'll be faster speeds. So basically, if I want more power at the shaft, I will go from small pulley to step it up to the middle one or the bigger one again. However, when I do that, the speed will be reduced by a percentage. I'm not sure of the percentage. So you can see there the pulley is roughly half the size, the wee one to the big one. So the speed will be reduced by half, hopefully, and with respect to the digital gears too, keeping them in mind. So what I'm going to do here now is finish off this mounting point so basically I need to run from this bolt to this shaft. The bracket that I already have made, I can use that. It's got an elongated hole there, you can see. I'll use that, modify it, and I'll take loads of pictures. So when this is completed, I then need to make an adjustable, sort of like a shock absorber, or this, I'm talking about this electric actuator. I might use that, we will see. It might be overcomplicate things, but we'll see how it goes. And I also need to support the end of this pulley. So that's it. We're going to move on now and take loads of pictures throughout all this very precise work in order to get this to work. So it's looking good. Okay, so this bracket, wee modification. So what I've done is I've cut the bracket at the fold, the bracket that I made initially along with this one. So I have now cut a wee angle on this, say approximately 30 degrees. So this offsets the shaft from this whole mounting point on the lathe by approximately, what is it, 30 mil. So this bracket now will be welded at this point, and the shaft will be cut here at this point and welded to here. So this allows, it stops any restrictions from the motor moving out between the first stage and the third stage parts of the pulley. So we will cut the shaft now and weld this up. Okay, so we have these two parts ready to be welded up. So this will be a support for the lower mount. So basically this plate will be welded directly to the plate that I have mounted to the lathe at the minute. So I'll tack this here now while it's holding it here. So that's tacked in position there now. So this plate needs to be perpendicular to this one, so 90 degrees at this point. This face to this face. Now this final piece will be set in here. Like so. So this is going to be a quite strong mounting point or bracket for this lower sliding point of the motor, as required. It's required. So I'll need to adjust this here now and tack this up. So at the minute, you slide this in a wee bit further. So what I'll do here now is I'll tack this to here. So it's kind of difficult to do all this while the camera's rolling. So what I'm going to do is I'm going to take loads of pictures of a stage, and then we'll do the demo, or sorry, the exact same process again with the mechanism that adjusts the motor in and out for the 3 different stages. So there'll be one mechanism, either be either electrical mechanism or be mechanical. I don't know yet, but I'll take loads of pictures right through, and hopefully it turns out well. Okay, so a little final video clip here of the lower mount finished, ready to be welded. So you can see here now I can slide the motor back and forward. Need a wee bit of grease in the shaft, but like so. So that means now that I can move between this 3-stage pulley quite easily if needed, if I needed to do this. So I'm going to slap the belt on here. So here we have the belt on for the lowest mechanical gear of the lathe. So it's the biggest, the largest diameter on the 3-stage pulley. Then if I want to move to the 2nd stage, I just do this, and the motor falls out further away from the spindle of the lathe. So I need to make adjustments from here now at this point to keep the belt tight. So I'm going to place the belt now in the 1st stage. So then I'll demonstrate the motor mount, the bracket at the bottom. So here we have the motor at the final stage here now, and you can see the belt's sort of skimming this bracket still. I only realise that now, so I'm going to have to make final more modifications. I will do this in a wee minute, but for the meantime it's okay. So now you can see that the shaft, or sorry, the bar, 60mm bar, is supported at this side as well as the right hand side here. So when the belt's been tightened by the mechanism that I will attach here, this bar doesn't pull in at an angle, and so it stays nice and straight. The belt stays nice and straight to this pulley, to this pulley. So I'm going to have to go here and sort out this wee So basically what I can do here is just take a wee notch out of this bracket when I'm finished, because that's the farthest that the motor ever comes over here. So basically you take a wee notch out of it. So what I'm going to do here now is I'm going to move on to the adjustment. So when I say notch, I just take a wee small cutting out of it with the grinder. Not very much. I just don't want the belt to skim it. So at the minute when the belt's tight, it's just touching it. So I'll do that now, and then we'll move on to the adjustment. Okay, so the lower mount is now finished. Before I start making the adjuster for the different stages or different positions of the belt to be tightened, I just want to mention that this spindle shaft is actually, I have dismantled it, this whole gear assembly, to allow the belt to be placed on this 3-stage pulley. So if you see this shaft or whatever sitting out probably 60mm too much, that's the reason being. When I paint the lathe, I will install that back in again, and yeah, take it from there. So where do we start now? Okay, so I initially says that I was going to use a shock absorber from this point here, from the lathe as frame to this plate that I have made to adjust the belt. But I have actually come up with a new plan today. So what do we just show here? So this shock absorber is, what do you see, it probably says the strength on it. It's under extreme pressure, so it's very hard to obviously push in. It's off a bootlet of a car. So I have decided not to use one of these. I had a 6-inch one of these. That would have been, well, better than that long one for here at this point. But the problem is, right, is when you're slackening the belt, you don't want to be putting too much pressure on it, because it's obviously dig into your hand, and you might need to put a lever on it and stuff. So I've come up with another idea now. So so here we have a gearbox and a motor and a screw assembly. So it's basically a screw shaft, linear screw, and like a worm wheel. And inside here we have a little gearbox, a little wheel for obviously a cog. The motor is placed into the cog and it turns it. And this screw is fixed to a point. So when you reverse the polarity and put 12 volts on here and back, it goes back and forward in and out. And the force is actually quite strong because I tested it. So this is out of a Honda Legend seat of a car. So I think it's for lifting up and down. That's why the stroke's so short. It's only about 80mm there approximately. So what I'm going to do now, right, is I'm going to make a bracket. And I am going to mount this little actuator onto the bottom of the motor. So this motor needs to move with when I'm changing between the 3 stages, because it doesn't stay in the same position obviously. So when I move this down, what do you see here, if I move this down to the lower pulley, I'm going to take it across. If I move this down to the lower pulley like so, sorry, I'm trying to use one hand here to do this. So if I move this down like so, you want the motor to sort of pivot with the frame, with this plate, but it needs to be independent of it also. So it so basically this pivoting point and the pivoting point on the motor mechanism needs to be independent from each other, but they need to be on the same axis sort of. So basically when the actuator goes out, this moves and the actuator moves where it wants to move. So what I'm going to do here now, right, I was going to make a nice wee, it sounds pretty technical, but when I make a bracket for it and make this pivoting point here, so there'll be 2 pivoting points. It'll pivot on the 16mm bar alongside the motor itself, and it will also be connected to the motor plate at this point. So we're going to do this now. We're going to make a nice bracket for this. We're going to get another 16mm bush and put it on here. This will be welded to this, and I'll be able to move it up and down. And basically when the shaft comes out, you want it to be flexible. You don't want it to be rigid, otherwise it'll start bending the shaft in the different positions. So we're going to start here now. We're going to start making a nice bracket for this, and a lot of work, but it's turning out quite well. So here we go. Okay everyone, so that's it finished. I hope you enjoyed all the little video clips, all edited together. So as I said at the very start of this video, I'm going to do part 3 on the tensioner part of the motor. So the tensioner has to adjust between the different gears, the mechanical gears. So basically I have to make it in such a way that it tightens when the motor is out full, away from the spindle, on a smaller gear, and then I have to make it tighten when the belt is on the bigger gear, so the one with the bigger diameter, so the actual motor will be in closer to the spindle. So I have to make this, I have to allow it to adjust between the different, the different speeds. So I hope you enjoyed. Please come back in hopefully about 4 weeks to see part 3. Thank you for watching. Okay, so additional design manufacture now. So here we're cutting the stainless 6mm plate for the brackets that will support the sliding bar for the motor mount. So at this point we are ready to fold it approximately a third of the way in. Here it's folded, so I didn't have the capabilities of folding this, so I cut it, I tracked it, and then I welded it up again. So there's 2 of these, one shorter than the other. This is actually the short one, I believe. So this goes to the right hand side. So this is the way I bent them, just over a girder. So I would have clamped it to the girder and just pulled it over with the spanner, the shifter. So this is the longer one, also done out of 6mm stainless. Okay, so here we have the longer one. You can see the tracks that needed cut there. So they were cut in a taper or down into a point, approximately 30 degrees. So here we have a track cut, ready to be folded nearly at this point. So it's just a much easier way of folding such heavier steel, and it can be welded up again rather than just welding 2 bits of metal together at an angle. Drilling the hole at this point. So this hole actually in the long one was elongated with the Dremel to allow fine adjustment. So at this point you can see me creating a hole, or an oval like hole or elongated hole, just using the carbide burr. So the brackets are mounted at this point, ready for the motor to be welded. However, we came into a problem here with the bracket on the left being in the way when I went to slide the motor over to the left. So this restricted me putting the belt on the lower, the smaller gear there, the smaller V pulley. So lots of pictures here just showing the detail that went into it. So this is a sliding bar, 16mm. You can see there it's sort of polished up, just to stop any grittiness when it has been slid along the bushings. So this is the motor mounted at this point, looking good. So on the larger pulley here we see the motor sitting closer to the spindle, and at the intermediate one and the smaller one we see the motor sitting further away from the spindle. So it turned out quite well. So the next exciting point is installing the tensioner itself, the electro tensioner, or the linear screw bar that you have seen at the introduction there out of a car seat. So this will be installed either at the bottom or the top, but I think it will be the bottom as the stroke. I want to keep a stroke as short as possible on the ram side of it, or the screw side of it. Okay, so here we see the motor lined up on the lowest gear, and then now it's on the highest gear. Just showing me samples here. So here's the problem we ran into here with this bracket. So this bracket needed to be moved way out of the way when the motor was over in the smallest gear, which is obviously the highest gear. So I needed to modify this bracket again. So I basically cut off the bend, didn't use the bend, and I ended up and run a 16mm bar out to it using another little plate cut at an angle there, approximately 30 degree there at the bottom and a wee bit less at the top. So the video demonstration showed this being welded together. Sorry, it was actually 30 degree at the top and 30 degree at the bottom, obviously. So them two angles, well, two lines is parallel. The angles are identical, only it is run off to the left, an offset away from that nut about approximately 30 millimeters. So you can see now that the motor can slide more further over. That's really the idea behind it. So it looks well there now. Fancy wee bracket, ready to be welded up. Okay, so this is the underside of the sliding bracket. Looking well. At this point, I needed to cut out the little notch to allow the belt to pass through. So any sharp edges also needed to be removed. So this was done just using the grinder to cut it out and then filed into a nice, nice neat edges. So perpendicular to the face there, them two faces, nice and square. So this is it showing it, the belt passing through. There's a couple of mil gap there. So the motor's only going to ever come over so far, so it doesn't need to be too much taken out of it. So that's it everyone, little teaser photos here of the little motor actuator that I hope to use to tighten and to slacken the belt in the 3 different mechanical gears. So thank you for watching everyone. I hope you enjoyed little detailed video clips, and yeah, part 3 will follow in hopefully 4 weeks time, and that's it. More interesting projects will also follow in the future, and thank you for watching everyone, and do come back soon. Thank you.